Good afternoon, everyone. Today I'm going to talk about a specific topic that is often ignored, mostly because it is related to a certain solution for our current global environmental dilemma. Today I'm going to talk about hydropower, a solution for humans, a challenge for salmon and steelheads. Nowadays, the current desperate search for solutions with no negative environmental impact has turned us blind towards the negative side effects all these new options are bringing us, affecting areas that weren't contemplated before. One of these problems are brought mainly by dams that are created for hydropower energy. Today, there are roughly 60,000 large dams around the world, with over 3,700 more planned or under construction. And at first sight, it might look like how can a dam affect the environment? Is there really an impact? But that's how we see it at first sight. But are we really seeing it from all angles? To understand its impact, it's important to know how a hydropower system works. As you can see in the diagram, uh, a hydropower works thanks to gravity. A dam is created, and because of height difference, it falls, uh, it falls and interacts with a turbine that will eventually create electric energy. Are you seeing my screen?
Yes.
Yes, we can.
Look. Oh, look. Uh, it falls, and it will. What we use is gravity. So we have this water reservoir, and depending of the height difference, the water is going to fall, interact with a turbine, and then create electric energy. And that's basically how hydropower works. But unfortunately, despite the lack of use of fossil fuels, dams can change the aquatic ecosystems of different regions. Since 1970s, freshwater species have already experienced a staggering 83% of decline, and is expected more decline with the creation of more hydropower systems. That is why today I'm going to mention the downsides of this clean energy. Dams are essential for this type, for hydropower energy, as you could imagine. These constructions basically create a physical barrier between the aquatic wildlife and its regular cycle. It has been found that more than 40% of the spawning and rebreeding habits for salmon and steelheads in the Columbia River Basin is permanently blocked by that. This affects the reproduction systems. Also, dams can lead to inundations that can affect the surrounding ecosystems. The existence of a dam creates a water reservoir that is not controlled. That if not controlled, it can surpass the limit and whip out historically productive spawning habits for the salmons and the steelheads, as you can see in the picture. Also, let's not forget the temperature changes consequences. Since it slows the water flow, it causes temperature to rise to levels that are lethal to salmon and steelheads. As you can see in the diagram, you can see the regular flow and the flow when you have a dam, and how it changes the pattern from symmetrical to asymmetrical systems. And this highly affects the living conditions for the salmons and the steelheads. And finally, but not least, the impact of slow water flow doesn't only increase the temperature, but it affects the sediment transportation. This alters the flow pattern and modifies the food webs. And as you can see in the diagram, you can see the pre-dam and the post-dam. And you can see how all these other species are entering or going out, altering what is normally for all the animals living in that environment. So it's important to highlight that each hydropower facility is unique and requires customized actions to minimize its effects on salmon. With this information, we are now able to identify that not every clean energy form is completely clean, and it always involves the impact somewhere else. That is why we need to understand that each hydropower facility needs to be treated differently, and we need to work together to find real solutions that have no negative impact on our environment. Thank you.
Thank you, Andrea. That was a very interesting presentation. Now let's see if some of our guests or the audience out there have any questions. Does anybody have questions?
Teacher, can I ask a question, please?
Of course, go ahead, Alan.
Okay, what exactly does hydroelectric power do for use in everyday life? Thank you.
What is it used for?
Yes.
So,
sorry.
What is it used for? This is the diagram, right? So you have water on one reservoir, and you use gravity, and you have a turbine. You can see on the diagram this turbine that when it moves, it creates electric energy, and then you can use that electric energy like to turn on lights and stuff like that. That's why people are starting to use these ones, because they thought it was a completely clean energy, since it only uses water, gravity, and a turbine that is later going to transform this mechanic energy, this mechanic energy into electric energy.
Thank you.
Thank you, Alan. Is there any other question?
I have another question, Miss Teacher.
Yes, Dana, go ahead.
Which solution do you think it's best for in order for us to use? Like as you said at the end.
So what I was reading is that one recommendation that people are trying to apply to the creation of dams, because here the problem of hydropower is mainly the dams, is taking in consideration the reproduction cycles of animals, and whether deciding if we need to increase the amount of water that's flowing from the dam to the turbine according to the cycle of the animal. That way we don't affect the reproduction cycle, and therefore we don't affect more animals.
Thank you, Dana. Did we answer your question? Well, we did. Andrea answer the question? Thank you. Thank you, Andrea.